Let's start lab 10. In what follows, use any of the following test procedures: regression, multiple regression, confidence intervals, one-sided t-test or two-sided t-test. All the procedures should be done with 5% p-value or 95% confidence interval. Upload cars data setup. It is believed that Mercedes price, suggested price are higher than BMW's. Given the data, your job is to confirm or disprove this belief. Careful, sort the data in order to extract the needed information. So we need to compare between the average price of Mercedes and BMW. Furthermore, we need to check whether price of Mercedes is higher than BMW. So since comparing two averages means t-test, and we need to compare if Mercedes price is higher than BMW. So that's one-sided t-test. Here I have uploaded the cars data, and firstly I would like to filter the data. Go to data and go to filter by using Mercedes and BMW. So that would be deselect all, Mercedes. So we are done with selecting all of Mercedes and BMW car. Okay, copy this data and go to new worksheet, Control V. So let us custom sort. So that's custom sort and sort by vehicle name. So okay, thus we got Mercedes-Benz, BMW in the top and Mercedes in the second. Okay, so this is the suggested retail price for all the BMW car that we have in our data, and this is Mercedes-Benz car, the price of Mercedes-Benz car. Okay, average price of BMW is 43379 point something. Okay, and average price for Mercedes-Benz is 55622. So that's for Mercedes. So here you can see that the averages of these two data, Mercedes is higher than average of BMW car. So the assumption is backed by the averages, so we are able to use the t-test. Okay, so let's go for t-test. Then t-test would be one tail t-test, so that would be equals t-test. First array is BMW, comma, the second array is Mercedes-Benz, comma, one tail test, and 3 for p-value. So that's the p-value, 0.80. P-value is 8%, right? So which is greater than 5%. So that's not a good p-value. And statistical interpretation, since p-value is very small, no. P-value is very small, no. P-value is very small, no. So none of these. Conclusion: yes, I am confident that the above assertion is correct. No, that's not. No, we cannot claim the above assertion is correct. Here we wanted to use one-sided t-test, and we checked the average price of Mercedes and BMW. So average price of Mercedes was higher than BMW, so we went for we were allowed to use one-sided t-test. Thus we get this p-value, which is 8% larger than 5%. So none of these are correct, so we go for none of these, and no, we cannot claim that since the p-value is higher. Upload cars data setup. It is believed that Jaguar's highway mileage is above that of Mercedes. Given the data, your job is to confirm or disprove this belief. Sort the data in order to extract the needed information. So Jaguar's highway mileage is above that of Mercedes, means greater than Mercedes. So this is also the case for one-sided t-test, since we need to compare between the Jaguar's highway mileage and Mercedes highway mileage. Furthermore, we need to go for to check whether Jaguar's highway mileage is greater than Mercedes. So that's one-sided t-test. Now we are dealing with the same data, so let us go to the original one. Thus here we already have Mercedes data, so that's fine. Let us rule out all the BMWs and select Jaguar. Okay, I think that's all. So click on OK. Thus we have Jaguar and Mercedes. And here let us copy this. Okay, let us copy all of this and Control C and paste it in a new worksheet. Control V. Here also again I need to go for custom sort. So custom sort by vehicle name. Okay, so Jaguar on the front. Okay, so to see the highway MPG, here up to row 9 we have highway MPG for Jaguar. So this is for Jaguar highway MPG. Since we are trying to use one-sided t-test, so we try to see whether the averages back the assumption of the question or not. Average highway miles for Mercedes is 24.46. This is for Mercedes, and this was 26.125 for Jaguar. The averages aligns with the assumption of the question, so we can do the one-tail t-test. So one-tail t-test equals t-test first array, that's this one of Jaguar, comma second array is this one, which is highway miles for Mercedes, and 1 comma 3, 0.0505, which is slightly larger than 5%, but we want less than 5%, so this is greater than 5%, so it's large. Okay, so yeah, one of the correct choice might seem just like this. Since p-value is large, we cannot claim that averages are different. Statistical interpretation is for two-tail test, okay, not for one-tail test, so none of these. Okay, and no, we cannot claim the above claim is correct, so that's our choice. Okay, since it is slightly greater. Okay, let's go for task 3, and here also again the same instruction is in the first line. Upload the car's data setup. It is believed that Lincolns and Cadillac have different weights. Okay, given the data, your job is to confirm or disprove this belief. Sort the data in order to extract needed information. Okay, that's fine. Lincolns and Cadillac have different weights. That means we need to compare the average weight of Lincoln with average weight of Cadillac. So that's two-sided t-test. Let's go for the same data again, Lincoln and Cadillac. Original data, so deselect all, and this one is Lincoln. Okay, so that's all. Then let us copy this and paste it in a new worksheet, and here let me custom sort the data. Custom sort by vehicle name. Okay, so Cadillac in top and Lincoln in second. Okay, so we are going for two-tail t-test for the weight. Okay, so up to fifth row we have weight of Cadillac. T-test equals two-sided t-test is t-test. The first array is this one, comma the second array is this one, comma two-sided test, comma 3 is for p-value. Okay, 0.5985, that's the p-value, which is a very large p-value, so we would go for, and it's not margin of error, p-value is large, we cannot claim that the averages are different. Okay, that's suitable. Yeah, p-value is small, no, so this is one. We cannot claim that the averages are different, and thus we cannot claim that our assertion is correct. Task 4. Upload cars data and make histogram using retail price column. Be careful how you choose bins. Use the shape of the histogram to answer the following questions for assessment. Okay, upload the cars data, make histogram using a retail price column. Okay, so let me go to original data. So this is all, select all. Okay, retail price. Copy this one, that's suggested retail price. Then to get an idea of bins, how to make bins, so I would just go for trying to see. Let me first draw a scatter plot to get an idea how we can choose bins. Okay, so insert and scatter plot. Okay, so this one. So this is the scatter plot for suggested retail price, and in y-axis we have the retail price, in x-axis we have the number of vehicles. Okay, all right. Okay, so for that I would go for 20,000 spin. So these are the bins. Okay, so 235 is the last column. Okay, then go to data analysis and go for histogram, click on OK. So input bin range is simply this one, so that's fine. And suggested retail price is A1 up to A235, $A $235. Okay, labels, there are labels. Okay, and click on OK. Thus we get this thing. Alright, thus we get this kind of frequency table. Now let us draw histogram out of this. So I have selected it, click on insert, go to column. Okay, to do column. So that's all. Okay, so this is the histogram. The histogram chart should resemble the presented shape as bell shape, double bell, skewed. Here you can see that this is slightly skewed. Okay, if it was bell shape, then it would have been symmetrical just like this, but it is skewed towards the left hand side. Now compute the median, standard deviation and average for the whole data set. Median of the data set, standard deviation and average. Then go to this one where we have all of our data. So then go for this one. Then the average is 29756. 29756, and standard deviation is equals STDEV A1 up to A235. Oh no, that's not A1, that's A2. That should be A2. 15,885, and median A2 up to A235, 26007. Okay, then I can see that standard deviation is less than median, is less than average. So average is highest, median and standard deviation. So this is the correct one. Upload a US crime data and make histogram using aggravated assault count column. Sort the data by crime first. Okay, use the shape of histogram to answer the following question for assessment. We have uploaded the US crime data, and let me just go for filter and types of crime. No, this is not the one. Crime is aggravated assault, right? So deselect all and click on aggravated assault and click on OK. So aggravated assault count is this one. Control C, and let me paste it to another worksheet. Control V. So let me just make this nice, and they are according to the number of years. According to the histogram chart should resemble shape as this. Okay, first row is A1 and the last row is 2 3 4 7. So let me go for equals to minimum. So that's the minimum. Okay, minimum is A2 up to A2 3 4 7. Okay, so that's the minimum. So minimum is 0, and the maximum value is A2 up to A2347. So you can see that the murder count ranges from 0 to nearly 200,000. So it's a quite variant data. Okay, so the minimum value is 0 and maximum value is nearly 200,000. So let's just go for 30,000 as our bin. Okay, container 30 1 2 3 30,000. So next would be 60,000. Okay, so that's it. Now let's go to histogram. data analysis, histogram, click on OK. So A1 up to A2347. Okay, that's fine. Then B would be up to 8. Okay, B8. So click on OK. Thus we got this thing. okay, this new table. So go to insert and click on this 2D column. So that's all. The curve is left skewed, that means it pushes itself towards the left of the graph. All right, so this is left skewed. Okay, histogram chart should be left skewed. And let us compute the mean, median and standard deviation. So for this one, average is simply, let's go for that, 128.68. 128.68. 128.68 point something, right? So this is average. And median, A2 up to A2347, and standard deviation ST equals STDV array 1 A2 up to A2347. Average is greater 12,868, 21,594. Standard deviation is greater than average than median. Standard deviation is highest and average than median, so D would be the correct choice. Okay, task 5. Open the pre-law nursing data setup. Do nursing and pre-law measures have different salaries? Given the data, answer the question. Hint, read lecture 24. Okay, that's fine. Does nursing occupation and pre-law measures, they have different salaries? So we need to compare the averages of salary of nursing measure and pre-law measures and compare their salaries. So that's case of that's a two-sided t-test. What would be the correct null hypothesis? Correct null hypothesis would be the population averages are equal, right? So that's the null hypothesis, and the p-value is 0.0006. What can be statistically concluded? We can conclude that we reject the null hypothesis since p-value is very less, right? But let us try to figure out p-value ourselves. Equals t-test. This is the first array, comma, okay, 0.00629. Okay, so that's fine. What would be an appropriate comment? So we cannot conclude that nursing and pre-law measures have different salaries. So since p-value is very small, so we can say that they have different salaries. We are confident that nursing and pre-law measures have different salaries, so this could be one. We are confident that nursing salaries influence the pre-law salaries. No, this is not about influence, okay, it's not about regression, so we would go for B, which is not the rule of thumb. Null hypothesis is always stated with an equal sign. That's true. Okay, go for these statements. P-value is good, less than 5%, then we reject null hypothesis. That's fine. P-value bad, then we accept the null hypothesis. This is not correct, since if you go to lecture 24 at the end, you can see that we cannot reject null hypothesis if p-value is bad. Okay, so that's it. So all things are done. Let us submit the lab. Okay, I got 110.